Okay, everybody. It looks like we may not have anybody this evening, so I'm going to go ahead and get started. Um, we are going to be talking about section 7.2, or I'm sorry, I'm just not quite sure. Evidently, I need a little bit more caffeine today. Sorry, we're going to be talking about section 7.5 today, and I'm going to go ahead and warn you. These can be kind of lengthy problems. It's kind of the culmination of chapter 7. So it requires a lot of the knowledge that we've done for the first 4 sections, kind of all combined into one for some of these problems. So you'll notice that you're having to rely on a lot of the things that you should remember from these last couple of sections. And when we do these, we're going to do all of them in what we call an exact answer, which means we're going to do a bunch of the math without grabbing our calculator. And then at the very end, we'll round this off and we'll grab our calculator for the very ending of these things. And that way, it either way, because Hawks will sometimes ask you, give me an exact answer. Sometimes they'll ask you for a rounded answer. Sometimes they ask you for both. So we're just going to go ahead and find both types of answers for every problem that we do today. And that way, kind of depending on what your homework happens to have, then hopefully you are prepared for both of them. So let's go ahead and get started. I have a couple of problems that I kind of went through the homework and picked. I want to caution you, this is not exhaustive. So you need to make sure that you're going back and looking at your learn and your practice mode and things like that. But these are a couple of, actually 5, the different types of problems that you could see. So the first thing that we are going to do is start with one that is an exponential problem. And we're going to do 2 exponential problems, and then we'll move over to the logs. So the first thing that we're going to do is this one, e raised to the x minus 5 power equals 123. So I want to remind you that there are a lot of different ways to solve different problems. So the way that I'm going to do this is certainly not the only way to do this, but I think it's probably the shortest. And a lot of times people like short because we like shortcuts. So that's one reason that I picked this one. So first of all, it is an exponential equation because it has an exponent. And if you'll remember all the way back in like the very beginning of this section, we learned how to change something that is an exponential equation into a log equation. And that's what you want to do first. And really that's kind of the heart of this problem. So I want to highlight something for you for a second. So I'm going to use a little different color right there. That E is the base. And so the base for your log, or the base for your exponential equation, is also the base for your log. And so when we change this, we are going to write log with the base of E. And then remember, what we're taking the log of is whatever's over here. So we'll be taking log with the base of E of 123 equals x minus 5. And remember, it equals whatever that exponent used to be. So since that exponent right here is this x minus 5, that's why this equals x minus 5. And then I also want to remind you of this. You will never, ever, ever in a textbook see the log base E written. Remember, the log base E is defined to be the natural log. And so I wrote log base E because I wanted you all to see what I was doing. But now I'm going to come in and I'm going to, instead of writing the log base E, I'm going to write ln because that is the natural log. Now, I'm the person that actually grades a final exam. And if you write log base E on a final exam, I know what you're talking about, and that's okay, but you won't ever see it written in a textbook. Okay, so now, believe it or not, you're almost there. So remember, the name of the game in any algebra problem really is to solve for x. Well, if you look at it, there's x right there. The only thing that's with that x is a minus 5. So to get rid of that minus 5, what we're going to do is we're going to add 5 to both sides. And then remember, those two things kind of cancel out. That's nice. So that leaves me with an x over here. But then over here on this left-hand side of my equation is a really common mistake because you're used to seeing things like this. And the first thing students think is, oh my goodness, yay, I can just add 123 and 5. But remember, you can't do that because that 123 is part of that natural log. And so your exact answer right here is just the natural log of 123 and then plus 5. And so I'm going to circle that. And then I'm going to write out beside it, that is what we call an exact answer. The reason that's an exact answer is because I did not ever pick up my calculator. So now if I was going to round that off, and I'll be honest, I've been doing math a long time, guys. I have no idea what that number is. If somebody were to say, give me a rough estimate, is it around 10 or around 35 or I don't know. So the only way that I can do that is to grab my calculator. Your calculator will have an LN button. So I'm going to hit LN 123. Now I have, and I know you probably can't see it terribly well, I'm going to hold it up right there. I have a TI-84. So if you'll notice, if you look at that very bottom, and in fact, let me clear my calculator out for a second, just so that you're not seeing anything else. If you look at that, when I hit LN, it opens a parenthesis for me. Well, the only thing that I want to take the natural log of is 123. So I need to, once I type that in, I need to come in and close my parenthesis. And then I'm going to add 5. And so if you look at this, okay, then you'll notice that none of these are real pretty numbers. Don't expect to get anything like an answer of 2 or anything like that. It's just not going to happen. And so what you're going to want to do is look at an answer like this and look at what they ask you in Hawks and say, okay, I need to round this off to, let's say, the 100th place. So if I round this off to the 100th place, well, that's 2 numbers after the decimal. So in this case, my answer would be 9.81. And I'm going to put just a little note right here that this is my rounded answer. Now the 100th place, sorry about that, guys. I forgot to put my cell phone on silent when I got here. The 100th place is not sacred. I just happened to pick it. I will do another problem in a little bit and we'll round to something else. So make sure that when you're doing your homework in Hawks that you read the instructions and how many they would like for you to keep when you round your answer. So let's erase this one. And we are going to do another exponential problem, but it's going to have one extra kind of step in it so that I can show you multiple kinds of exponential problems. So this one, we'll call it problem number 2. And it's still going to have an E. One of the reasons I picked things that had E's in them is because students get really nervous about an E. And so I wanted to make you realize that, we can work with an E. It just means that you're dealing with a natural log. And so this one is going to be 3e to the 2x plus 1 power equals 75. So once again, this is an exponential problem because it has an exponent. But here's the crucial difference between this and problem number 1. And I'm actually going to put some parentheses around this, and I'm going to put them in a different color so it kind of stands out. This right here is your base and your exponent. E is what's being raised to the 2x plus 1 power. That 3 right there is really just being multiplied by all this. That 3 does not go with that exponent. So since it does not go with that exponent, the first thing you have to do is get rid of it. So since that is 3 times e to the 2x plus 1, the only way that we can get rid of that is to divide both sides by 3. Now, if we do that, we know that those 3 cancel. That gives me e to the 2x plus 1 power. And then 75 divided by 3 is a nice number, so I'm going to go ahead and write that down, and that's going to give me 25. Now, once you do this, if you really notice, this is almost the exact same problem as problem 1 was. Now, you have e to a power equals some number. So what we're going to do is we're going to take it out of exponential form, and we are going to put it into log form. So remember, this is my base, so that's going to be the base for my log. So it's going to be the log base e, and then we're going to be taking the log base e of 25. And then we set it equal to what that exponent was, which in this case is 2x plus 1. Now remember again, I'm going to get my eraser up here. I'm going to come down here and I'm going to erase this because we won't ever see the log base e written anywhere. That is the same thing. It's by definition, the log base e is defined to be the natural log. Now, once again, you're trying to solve for x. And so if you'll notice, x is over here on the right-hand side. We've got a 2x plus 1. So you always want to get rid of something that's being added or subtracted first. So the first thing that we are going to do is come in here and we're going to get rid of that plus 1. And the way that we're going to do that is by subtracting 1. And remember, you cannot combine that 25 and that minus 1. So this is just going to be the natural log of 25 minus 1, and then it equals 2x. Okay, so we're almost done, but now we have a 2x. Well, the only way to get rid of a 2 in front of my x, since that is 2 times x, is to divide by 2, and that'll cancel those out. And so then what that's going to give me for my final answer, that is an exact answer, is going to be the natural log of 25 minus 1, and then all of that is divided by 2. So I'm going to circle that. If you were plugging this into Hawks, you would need to be very, very, very careful and make sure that your fraction bar goes with everything, not just with the ln of 25 and not just with the 1, everything. Now, this is also where you need to be careful plugging it into your calculator. So I'm going to try to kind of hold this up. You'll notice that you have multiple things in the numerator. So if we're going to do this, all right, I cleared this out. First thing that we see in the numerator is ln of 25. Now, remember, we talked about it last time. My calculator opens a parenthesis, so I now have to close it. And then minus 1. And then I'm going to do the typical student mistake. This is what students do a lot of times. They'll just kind of type it in. They'll do ln of 25 minus 1 divided by 2 equals. And they get some number, and then they wonder why they got it wrong. I want you to realize something. What you've done here is actually incorrect. This is not the right answer, because you have only divided that 1 by 2, not the entire numerator. So if you're going to do this and you're going to plug it into the calculator all at one time, what you have to do is put this overarching set of parentheses around the entire numerator. So I'm going to put parenthesis ln of 25, close the first parenthesis. So mine is going to look like this. So if you'll notice, this looks very different. What I'm doing is the ln of 25 minus 1 all first, and then once I get an answer for that, I'm going to divide it by 2. And I want you to look, I have a very, very different answer. This second answer is what is correct. So I should have 1.11 if I was going to round to 2 decimal places for my answer. So you do have to be very, very careful when you're plugging these into your calculator. A lot of times students think, oh, I did the hard part, which you really did if you get the exact answer, but you're not quite home free. You do have to pay attention to how you plug that in. So be real careful about that. All right, so we've done a couple of exponentials. I want to do a few logs because logs are the ones that tend to involve just a bit more algebra. And sometimes they're a little bit longer. And they also involve those properties of logs that we talked about last week. And then they have one other catch. And this is really important, so I'm going to write it down before we start with any of these logs. If you start with a log equation, so here's our first part of our rule. If you start with a log equation, you must check your answer at the end. Now you'll notice on those last couple of problems, I did not check my answer. And the reason is because I didn't start with a log equation. I started with an exponential equation. Now I ended up with a log equation somewhere in the middle of that problem, but I didn't start with it. And so if you don't start with a log equation, then you don't have to check it. But if you do start with a log equation, you have to check your answer. So make sure that you keep that in the back of your mind somewhere, okay? So there are multiple different kinds of log equations. And y'all know in math, when, teachers are going over things, we never really start with the most difficult thing right out of the gate. So we're not going to do that here either. We're going to start with one of the ones that is shorter, and then we'll get to the ones that are just a tad bit longer in just a second. So this one is kind of as nice as I can make it. Now, it does have ln, and I know a lot of people don't really like ln, but I want you to notice something. Over here, you have one thing. You have the ln of one thing in parentheses. That's it, okay? Over here, you also have the same thing, ln of something else. So you have the ln of basically this first quantity on the left side equals the ln of the second quantity on the right side. And so you'll notice that there's an ln on the left and an ln on the right, one on each side. The really nice thing about math is if there is one log on the left and one log on the right, you get to cancel them. And that is lovely. Okay, so what that means is that we can come in here and say, I don't want to deal with that anymore. All I have to do is set this first parenthesis equal to that second parenthesis. That's it. And then solve for x. Now, I want to caution you, you can't do that all the time. So don't get too excited and think you're going to get to do that on every problem. You won't. But you can do that if you have one on the left, one on the right. Not two on the left and one on the right. One on the left, one on the right. That's it. Once you do this, then you'll notice, okay, so we have x minus 9 equals 3x. So I'm going to combine my x's by subtracting x on both sides. That'll cancel these. Leaves me with a minus 9. 3x minus x is a 2x. And once again, I'm trying to solve over here for x. So what I want to do is divide by 2. And what I get is x is equal to negative 9 over 2, or if you prefer a decimal, you would say x is equal to negative 4.5. But now I want you to realize something. I have not yet circled my answer because I haven't checked this yet. So you have to now take this and go back and plug it in. Now, most of you are not real fans of fractions. So when you plug this in, you're probably going to take the negative 4.5, and that is perfectly fine. What you want to do is when you plug this in, you want to kind of come up here and you want to say, okay, so instead of x, we have negative 4.5. Negative 4.5 minus 9. What is that? So negative 4.5 minus 9. Well, if you don't know that and you're trying to double check it, you can, of course, use your math skills. Those are both negative. So we add them up, keep the sign of the negative number, or you can simply grab a calculator, either one. But when you do this math, you're going to figure out that negative 4.5 minus 9 actually equals negative 13.5. Now, you probably remember from a previous section, you are not allowed to take the log of a negative number. And by plugging in what we found for x, this says, hey, we're supposed to take the natural log of negative 13.5. Well, we can't do that. It's not defined. If you don't believe me, let me come over here. Let me grab my calculator again. I'm just going to plug it in for you and show you what happens. The natural log of negative 13.5. So you see, I've kind of got it in my calculator there, natural log negative 13.5, enter, and you'll notice it tells me error, non-real answer. Well, crud, that means I can't do this. And so what that means is that this negative 4.5 that I have found does not work. So, that doesn't work, but that was my only candidate. So since that was my only candidate for an answer and it doesn't work, what that means is that for this particular problem, there is no solution. Now, that's not terribly common, but it's common enough, and it will probably happen to you on your homework. So that's one of the reasons that I picked one of these to have no solution, so that you could see that that really does occur at some point in time. All right, so let's try, oh, didn't hit my eraser, hit the pen. Let's try a different problem. So this one is also going to start out as a log. And so it is going to be one that we are going to need to check our answers at the end. I don't think this one is a no solution, but we'll just see. So the instructions are to solve, but this one's kind of lengthy. So I'm actually not going to write the word solve because I think I'm going to need the whole page here to solve this problem. So it's going to be the log base 2 of x minus 2 plus the log base 2 of x plus 5 equals 3. Okay, so this is not a problem where you can just cancel out the logs like we did on the last problem. There are multiple reasons for that, but the main reason is, remember to cancel the logs, one on the left, one on the right. That's it. Notice you have 2 logs on the left and none on the right. So that is certainly not a 1-to-1, so can't do that. But what you should notice is that you have 2 logs over here. And so there is a rule, and in fact, it's important enough, if you want to, you can write this one down. If you have 2 logs on the same side of the equal sign, the first thing you want to do is combine them. Now that goes back to section 7.4. You have to remember how to combine them. Well, if you'll notice, these 2 logs right now are separated with this. They're separated with a plus. So when we did that section and we learned how to combine logs and pull them apart, if logs were separated with a plus, when we combined them, we needed to multiply them. So that is exactly what we are going to do here. This is going to be the log base 2, because remember, when we combine logs, we don't change the base, of x minus 2 times x plus 5. And then it's still going to equal 3 over here. So since they were separated with a plus, we're going to combine them by multiplying. Now you'll notice that you have 2 terms and 2 terms, so this really is a FOIL operation. So we're actually going to work this out. So here we go. Log base 2 of, now let's FOIL this. So FOIL stands for first times first. So x times x is x squared. And then if we do the outsides, x times 5 is 5x. And then if we do the insides, negative 2 times x is negative 2x. And then if we do the last, negative 2 times 5 is negative 10. And then this equals 3. And then if you look at that, when you FOIL something, almost always you can combine something. And so we can combine the positive 5x and the negative 2x. So this is going to be the log base 2 of x squared plus 3x minus 10 equals 3. Now, y'all, this is a lot of work, and we're, to be honest with you, only about halfway done. So what you have done so far is taken these 2 logs and you have combined them according to their rules. So since they were separated with a plus, we multiplied. And then you've simplified that. So we went ahead and FOILed it out and combined our like terms. Now you'll notice what you have is you have 1 log over here on this left-hand side. You do not have a log on the right-hand side, so you cannot cancel those 2 things out. The only other thing that you can do is change it from a log equation to an exponential equation, and that's what we're going to do here. So to change this, you always start with your base. So remember, 2 is your base, so this is going to be 2, and we're changing it to an exponential equation. So this number over here is going to be my exponent, so 2 to the 3rd equals whatever we're taking the log of. In this case, that x squared plus 3x minus 10. So that is a switch from one form to the next. So start with your base, 2, raised to the 3rd power equals, and then whatever that log was, in this case, x squared plus 3x minus 10. Now, if you look over there, 2 to the 3rd, 2 to the 3rd, if you'll remember, means 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8. So what I'm going to do is write that down. So what I have is now is 8 equals x squared plus 3x minus 10. And if you'll remember, this is a quadratic equation. Okay, quadratic equation can only be solved unless one side when one side equals 0. So we're going to subtract 8. So we're going to get 0 equals x squared plus 3x minus 18. And then if you remember, from a quadratic equation, you can do one of two things. You can either factor it, or you can do the quadratic formula. Most people, when they get to this point right here, are not huge fans of factoring. But if you are capable at factoring and you're pretty good at it, I'm going to tell you factoring is shorter. Now, factoring does not always work. In this particular problem, it will. Okay, but it doesn't always work. What will always work is the quadratic formula. So since the quadratic formula will always work, what I'm going to do is come over here for just a second and I'm going to erase kind of this very first part. I'm going to leave that original problem just so we can refer back to it in a minute. And we are actually going to now use the quadratic formula. And then I'm going to remind you again, if you don't remember your midterm, the quadratic formula was on your midterm, and I'm going to promise you the quadratic formula is going to be on your final too. So if you don't remember it, make sure you memorize it for the final. So this is your quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. Now remember, a in this problem is 1 because it is 1x squared. B is 3 because it is 3x. And C is negative 18 because that was a minus 18. So that's where we get our C. So now if we can come in and say, okay, negative b, so that's negative 3, plus or minus the square root of 3 squared, that's b squared, minus 4 times a, which is 1, times c, which is negative 18, all over 2 times 1. Okay, so that's kind of a lot, but here we go. So negative 3, there's nothing I can really do with that. Plus or minus, first thing that I see is 3 squared. Well, 3 squared is 9. And then if you want to, you can grab your calculator and you can say, okay, negative 4 times 1 times negative 18. Well, that's going to be a positive 72 over 2. And then remember what you want to do now is you want to add 9 and 72. So I'm going to move down here. So this is negative 3 plus or minus 9 plus 72 is 81 over 2. So that's the square root of 81. Now remember square root. So the square root of 81 is actually equal to 9. So that's negative 3 plus or minus 9 over 2. And then since you have numbers here, you can actually split this apart. And in fact, I'm going to do it in 2 different colors here. So one of these would be negative 3 plus 9 over 2. And if you'll do that, negative 3 plus 9 is 6 over 2. Well, that is going to equal 3. Another one of these is going to be negative 3 minus 9 over 2. So negative 3 minus 9 is negative 12. Divided by 2 is negative 6. So you get 2 answer choices. But remember on these are the problems that started out as a log. So I left the original problem up there for you so that we could see. So we have to check our answer. And what you want to do is make sure that it's not giving you the log of a negative number like it did on problem number 3. So the first thing I'm going to do is I'm going to take my 3 up here and we're going to look. So if I come up here and say, okay, 3 minus 2. Well, 3 minus 2 is 1. That's a log of a positive number. So that's okay. And then if I come over here and I say, okay, 3 plus 5. Well, 3 plus 5 is 8. Once again, that's the log of a positive number. That's okay. So 3 works. That's great. We like that. So now that 3 works, please don't assume that the other one works. You got to test them both independently. So I'm going to come in here and say, okay, now let's try negative 6. So negative 6 minus 2. Well, negative 6 minus 2 is negative 8. We're done right there because we can't take the log of a negative number. So this one doesn't work. So my only answer here is a positive 3. So a lot of times, just so you know, this happens on problems that are lengthy like this and they have two answers. When you get problems with two answers, you need to kind of have a little bell going off in your head. A lot of times that means one works and one doesn't. It doesn't always mean that. You can have them where both work or where neither works, but generally it's one that works and one that doesn't. So be real careful on those. All right, so for our last problem this evening, we are going to do one that's similar to this, but it's going to involve some fractions. So I know sometimes fractions are challenging for everyone. So we are going to go ahead and practice one of those together, see kind of how this goes. Okay, so once again, I'm not going to write down, oh, I picked the wrong draw, y'all. There we go. Let me erase that real quick. Pick the one that wants to not let me type with a finger. There we go. So once again, the instructions are going to be to solve, but I'm not going to write that down because it's kind of lengthy. I'm going to need the whole, doing this on a little computer screen is not really the biggest of whiteboard spaces. So I'm going to need all the space that I can get. So this one is going to be log base 2 of x plus 3 minus log base 2 of x equals log base 2 of 5. So I picked this one for a couple of reasons. First of all, it's going to have a fraction in it, and people get a little leery of fractions, and I understand that. Second of all, a lot of times students will see a problem like this, and the first thing that they think is, oh my goodness, yay, I can cancel logs. And yes, you will be able to, but not right now. The reason that you can't do it right now is because if you look at this problem, you actually have two different logs on the left, and you can only cancel logs if you have one on the left, one on the right. That's it. Nothing else. One and one. Okay. So if you look over here, these two logs right now are separated with this minus sign. So if you go back to what Mrs. Young talked about on Thursday night of last week, that means that when you combine these, you're going to divide. So we're going to come in here and we are going to say, okay, the log, remember when you combine, don't change the base. So log base 2 of x plus 3 divided by, and see it's minus log base 2 of x, so divided by x equals the log base 2 of 5. Remember, the log that is in front, or the log that is the positive log, is what's going to go in the top, and the one that is being subtracted is what's going to go in the bottom. So that's why the x plus 3 must go on top and the x must go on bottom. You don't have any choice or any leeway there. But now, if you can get to this step, what I want you to realize now is you've combined these two logs. So guess what? You have one log on the left, you have one log on the right. So if you have one and one, you get to cancel them, which means that we get to come in here and say, okay, this log base 2 is gone, this log base 2 is gone. So what we can do now is say, okay, x plus 3 over x is equal to 5. And so it's not a great problem because I know you're still thinking, well, lovely, it has a fraction, but at least you don't have the fraction and the log. So that's kind of a good thing. So let me remind you, when you are trying to clear out a fraction, what you want to do is multiply both sides by the denominator of that fraction. So the denominator is an x. So we're going to come in and we're going to multiply both sides of this by an x. The reason that you multiply by the denominator is because that clears your fraction. The reason it clears your fraction, come in here and look what happens. This x and this x cancel out. And so that just leaves you with x plus 3. Because remember, if you have one on top, one on the bottom, they can just cancel. Now over here, this has nothing to cancel with. So that just leaves you with 5x. But this is probably a little bit easier to solve. And so what I can do now, and I'm going to kind of do it in a different color, and I'm going to have to do it small. I shouldn't have written quite so big right there. We're going to subtract an x, and we're going to subtract an x. So if I do that, that's going to come over here. Those are going to cancel, leave me with a 3. 5x minus x is 4x. We're trying to solve for x. So we are going to now come in and divide by 4. And so I get x equals 3/4. I'm not going to circle that yet because remember, I have not checked my answer. But if you don't like that 3/4, you could always round that off, or, plug it into a calculator. You could know what 3/4 is, something like that. You could get 0.75. But once again, I haven't circled this because I haven't checked my answer. So to check my answer, remember I need to go back in and make sure that I'm not trying to take the log of a negative number. So if I take my 0.75 and I come up here and kind of plug it into this original problem, well, that would be 0.75 plus 3. Well, 0.75 plus 3 is 3.75. That's a positive number that I'm taking the log of, so that's good. Over here, x, just plain old, just plug it in. That's 0.75. Now it's less than 1, but that's not what I'm worried about. It's positive. So yes, that works. And then over here on this side, you don't even have any place to plug it in. That's just equal 5. So what that means is that this works. And so I'm going to circle both of those because depending on how Hawks asked you for it, if they said, hey, you can give me a decimal, you could give them 0.75. If they said, nope, you got to give it to me as a fraction, you would have to give them 3/4. All right, but you do have to check your answer, so be real cautious about that. I'm really going to suggest as I close out here tonight, guys, this is a section you're going to have to go through the learn and practice mode. If you haven't been doing that diligently, I'm pretty much betting that it's going to happen in this one. In my personal opinion, this one can be a difficult section. You might need to spend a little bit of extra time on it. On the positive side, there's only a few more sections left, y'all. We are like less than a month away from final exams, which, hey, that's a good thing. We're coming up to summer. So keep hanging in there. Be sure to let me know, or Miss Young know, if you've got any questions that you want to talk about. And other than that, we will see you next time.